In the previous video, we went through the compose settings, which really is determining what your chunks look like. Creating chunks is one of the first steps in this overall process of knowledge stacks. So the first step was really gathering all of your data. You want to make sure that you're adding the right information to the knowledge stack, because if you have bad data that you're adding to the knowledge stack, then you risk the chance of feeding the model incorrect data, which is going to provide bad results. The next step, what we saw last time, is really how do we want to chunk all this data that are going to ultimately be context that we want to send over to the model. But then the next step after creating the chunks, and this is really something that's going to be happening behind the scenes, is that the embedding model is going to take these chunks, which it translates as a vector. So one chunk equals one vector. And then the embedding model is going to analyze it and then convert it into a whole slew of different dimensions. Meaning it's going to assess the chunk or the vector and then look at all the characteristics that it represents so that it could basically semantically map it. Okay, let's close out the chunks visualizer and go back to compose settings. So really what we're going to be focusing on in this video is the embedding model. As mentioned before, there's a default local model here, which currently is called GTE Tiny. And this is the default embedding model that's going to be used if you don't select anything. However, if you have local embedding models or online embedding models that you want to use instead, you're going to see a list of embedding models that you have marked as such. And real quickly, let's X out of this and go to the model hub. So if you have a provider like Gemini where you want to add an embedding model, you could search for the embedding model and then add it to your list. Just make sure that that embedding model is marked with the purpose embedding. And you can do that maybe the easiest through the model selector right here. And then click on the little edit icon. And then where you see update model and purpose, you want to make sure that embedding is selected. If embedding is not selected for the model, then it's not going to show up in that list. If you haven't made a selection yet of what embedding model that you want to use, and maybe you're considering using one other than the default that we have, let's go through what options that you have available. So just like with any AI model in Msty that you're chatting with, you could bring in pretty much any online model or local model that you want to use. Very similar for embedding models. So you could either bring in online models and use those or local models. So you might be asking, well, what is the difference? What is the benefit of online versus local? Well, here are some important bullet points to consider. So if you're using online, just like if you're chatting with an online provider like ChatGPT or Gemini, when you're chatting with the online provider, you're sending that provider all that data. Whatever attachments you add, whatever information you make available, that's going to be sent over to that online provider as context. Same is true with online embedding models. If you are embedding a document, then that document is going to be sent to that online model where they're going to process it there and send the vector results back to Msty. So if you have important, sensitive information that you don't want to risk getting out, you don't want to risk going over to an online model and potentially have them training on it or having access to that sensitive information, then use a local model. A local model is always going to be much safer because everything is running on your machine. You can even turn off your Wi-Fi, close your network connection, and still run all that locally. And of course, another thing to consider if you're doing this online, factor in any cost considerations that there might be. All right, let's look at some examples of some of the top online and local embedding models that are around today. If you're considering online, Cohere Embed version 3, Gemini Embedding 004, OpenAI Embedding 3 Large, these are good online embedding models for your consideration. You'll notice these numbers next to the embedding models. These are the default dimensions that are supported for that model. So dimensions are going to be very important, and we're going to cover that a little more in the following slides, but just adding the dimensions here for reference. And then, of course, some of the local models that are pretty popular right now are the Arctic Embed, Mixed Bread, Stella, Nomic, and then what Msty uses by default is GTE Tiny. Okay, let's get more into what you should be looking for with an embedding model. One of the key things is to evaluate on the data that's being provided. Don't just rely solely on benchmarks. A lot of those are vanity metrics, and certainly they might tell you certain things about the model, especially around performance, but the key thing is what model is working best with the data that you're providing it. And a great way to really evaluate that, which I'm going to show you later on in this video, is test it with search results. You want to test and see what is actually going to be provided to the model as context for that model to provide you a good answer to your questions. And of course, with that, some models are inherently more of an expert in different areas. Like if you're looking at Gemini, probably going to be better for coding. If you're looking at a ChatGPT model, probably going to be better for research. But really find the model that supports the domain of information that's going to be provided. Another thing that you might want to consider is exactly how many files you're converting. Potentially a little counterintuitive, but if you have a large amount of docs, you're probably going to be more interested in efficiency over quality. Meaning you want a model that's able to go through all these documents, which might be a smaller model that's going to be a little more performant when vectorizing a vast sum of information. Whereas for small amounts of docs, just focus on the quality, and a larger model might be able to do that better for you. But again, evaluate these. The last thing I have here is dimensions, which I have a slide that's following this that will go through it a little better. But again, think of dimensions as all the different characteristics of a chunk or a vector. Maybe it's a little difficult to kind of wrap your mind around that when you're looking at just a wall of text, but think of a picture and then think of all the characteristics of that picture. Like who's in the picture? What do they look like? What are the characteristics of that person? Is there no person? Is it a landscape? What's the characteristics of the trees? Are there no trees? Is it desert? Does the desert have a certain type of rock? Does it have any kind of vegetation? Does it have any animals in it? All these are just different bits of information, different dimensions that work together to describe that image. Same thing with text. Dimensions are describing this chunk of text that's called a vector. And another thing that might be a little counterintuitive is you're thinking, oh, well, in that case, the more the better, right? Well, not so fast. So right now, the sweet spot in terms of the number of dimensions that would be useful is somewhere between 768 and 1024. That's kind of the sweet spot range where with that amount of dimensions, you're probably going to get really good quality matches. But if it's something that exceeds 1024, past 1536, you're just going to have too much. Just think of it now as, okay, well, now you're just overanalyzing it. There's too much noise, and now the quality is diminishing because of that. All right, let me try to visualize this and see if I could tie it all together. Let's consider this original text, which is one chunk or one vector. The cat sat on the mat. As this goes through the embedding model, what are all the different dimensions of the cat sat on the mat? And really, what are all the semantic similarities and differences of the cat sat on the mat? Well, cat is just one word. What are other words that describe a cat? You might say kitten or feline. All these are semantically very similar to a cat. Well, what about sat? Well, sat is a particular tense, in this case being past tense, but what about sit? If you saw a kitten sit on a mat, would you want that to also show up in the results? The answer is, oh yeah, for sure, because semantically that's very similar. So what's happening here is the model, the embedding model, is breaking this all apart and creating a vector with all these different dimensions, all these different ways that can relate back to the cat sat on the mat, either with a quality match, that there is similarity, or a mismatch, there's not a lot of similarity. And now with the different models, and in our examples, we're using Arctic Embed, Gemini Embedding, GTE Tiny, and Cohere Embed version 3. What we're looking for is if I have a line of text that I sent in, what approximately is the matching value between that text and the original text? Well, let's say that Snowflake is going to mark it as a 91% similarity. Google is going to one up it a little bit and say 94%, whereas GTE and Cohere, they're in the 80s. So these two would show up as highest match, and these two would show up as, kind of a high, maybe medium match. So then the goal is, okay, so these are a higher match. Does that provide the better quality that I'm looking for? And to test that out a little more, let's go back to Msty Studio. Okay, so back here in Msty Studio, I have 4 examples here where I use different embedding models. So all these examples, chunks look the same. So we're not going to look at the chunks visualizer to really assess how well these are, but we'll look more so at the chunk console. All right, so in this first one, we're going to assess GTE Tiny, and let's do a quick query. What I have added for all these is just the Msty Studio documentation. So they're all working off of the same exact file, and again, all chunked exactly the same, of course. All right, so let's go in here and then type Safari. because there's a particular way that you would have to set up Safari with Msty Studio Web. So let's see what kind of results we get off of that. Okay, so looking through this, I see some information about Mac download, but I'm not sure I see anything about Safari. So with this, I have this one result, and the context is kind of maybe not the best that I want to send over. All right, let's compare that against maybe a bigger model, because again, GTE Tiny has a smaller amount of dimensions. Let's select something that has a higher amount of dimensions, such as Gemini. And then go to the chunk console, and then again, let's type in Safari. Okay, I could tell right away that this is already a better match that I would want to send over to the model, because specifically it's talking about Safari and connecting it to Sidecar and using tunneling in order to work. So that is a very good quality match. So I could already tell with the Gemini embedding model, I'm probably going to have better results that I'm going to send over to the model. But instead of looking at the chunk console, hey, Msty has this pretty cool feature called split chats. Let's use that. Okay, I have my split chat set up, so I have 4 different split chats, and each of these using Gemini 2.5 Flash is assigned a different knowledge stack. So all of these are going to use a different knowledge stack that was embedded by a different embedding model. All right, let's see what the results look like. Okay, and right away I could see 2 that are pretty minimal, and it looks like maybe we have a good one here. Okay, I mean, it's slightly better. It's giving me a little more information. Let's see what this one on the right looks like. Ah, here we go. Sidecar's experimental tunneling feature allows you to access local AI. Okay, so this one on the far right gave me maybe the best results that I would want. Let's see which embedding models helped out our response model better than the other ones. Okay, this very first one was Arctic Embed. All right, so Arctic Embed, kind of, pretty blunt. That's true, just not a lot of information. And then the second one here was Gemini Embedding. Okay, so slightly better information than the first one and then this third one. I'm guessing this third one is probably the default that we have, which it is, GTE Tiny, which means Cohere provided the best results in terms of the embedding models that we used. And of course, when I did this, I just use all the default settings for search. So if you go here and click on knowledge stacks and then click on configure, in another video, I'm going to show you how you could configure these search settings so that even maybe if you're using one of these that with the defaults didn't provide the best results, maybe we could get it to provide better results. All right, I hope this video was helpful and helps you understand a little more how embedding models work and also how you might go about choosing the best embedding model for your needs.